Hi ladies, this is Mrs. Blaufuss and today is October 3rd. So these will be the notes for October 3rd through October 4th, 2019 for geometry. So we're just going to start off with a little bit of review. So to start, I want you to take a minute. You can pause the video while you work and then you can unpause for the solution. So please just take a look at this, and there are 3 questions and then a point about the third bullet point. So here's what you should have here. If you name the angle by the vertex, it's angle A. By a number, it's angle 1. 3 points, you could have either angle BAC or CAB. Just note that the vertex must be in the center of the angle name. So in this next part of your note sheets, again, which you can find on my DSHA under October 3rd through 4th notes, see what you remember so far about angles. If you look at your note sheet, there was a typo, so cross that part off, just like I have done in here. You can pause the video while you work and unpause for the solution. And here are the solutions for the second part. So angles are always measured in degrees. There are 360 degrees in a circle, which means that 1 degree is equal to 1/360th of a circle as a fraction. A right angle is equal to 90 degrees, an acute angle is less than 90 degrees, and an obtuse angle is greater than 90 degrees but less than 180, and a straight angle is equal to 180 degrees. So in this lesson, we're going to look at the angle addition postulate. And the angle addition postulate says that if point S is in the interior of angle, I'll say angle, of angle PQR, then the measure of angle PQR is equal to the measure of angle PQS plus the measure of angle SQR. Okay, let's write that out and see what that looks like. So we have point S in the interior of angle PQR. So let's make that angle. Here's angle PQR. P, Q, and R. And we have S somewhere in the interior. Doesn't really matter where, but it just has to be inside. Then we can draw a ray or something that goes from Q through S because we want it to form another angle. So we're saying that the measure of angle PQR this angle right here, angle PQR, is equal to the measure of angle PQS, which is this angle right here, plus the measure of angle SQR, which is this angle right here. Okay, so that's the angle addition postulate. So we're going to use that angle addition postulate to answer these next few questions. So the first one, it says rewrite the angle addition postulate using the given angle names. So we're saying that the measure of angle ABD is equal to 37. And here we have ABD. Oops. D is up here. Here we go. There we go. ABD is equal to 37 degrees. And measure of angle DBC is equal to 25 degrees. So we're going to rewrite the angle addition postulate. The angle addition postulate says that angle ABC is equal to the sum of the 2 smaller angles. So it's equal to angle ABD plus angle DBC. So now we can substitute using the values that are given. So we still don't know angle ABC, but we know that that's equal to ABD, which is 37 degrees, plus DBC, which is 25 degrees. And then lastly, we can solve for the missing angle. So angle ABC is equal to 37 plus 25, which is 62 degrees. And I would use the degree symbol. There we go. Okay, so let's try the second one. It says the measure of angle ABD is 29 degrees. I'm just going to write that in there. And the measure of angle ABC, that whole thing, is 66 degrees. We're looking for the measure of angle DBC, which we don't know, so I'll just put a question mark there. And we're going to rewrite using the angle addition postulate to start. So our postulate doesn't change. Still the larger angle, ABC, is equal to the sum of the two smaller angles, which is ABD plus angle DBC. But now when we actually substitute our values, and we know angle ABC, which is 66, so that is equal to ABD, which we know is 29, plus angle DBC, which we don't know. And then we can use algebra. We'll subtract 29 from both sides, and when we do that, we get 37 is equal to angle DBC. Why is this not working? Here we go. DBC. And again, make sure you use your degree sign. Okay, our next section talks about the angle bisector. So we've had this already. An angle bisector is a ray that shares an endpoint with the angle vertex, and it divides the angle into two congruent angles. Now the second thing that we want to know about the angle bisector that we learn in this lesson is that every point on the angle bisector is equidistant, meaning the same distance, from the sides of the angle. Okay, so we're going to use that, especially this part, when we get to the actual construction of an angle bisector. But to solve these next two problems, we're going to use a little bit of algebra, and we're going to use the definition of the angle bisector, which says the angle bisector divides the angle into two congruent angles. Okay, so in the first problem, it says find x if the measure of angle 1 is 3x minus 3 and the measure of angle 2 is x plus 9. Well, we know that because AP is an angle bisector, we know that angle 1 equals angle 2. So we can come up with an equation that sets those two equal to each other. So 3x minus 3 is equal to x plus 9. And then we can use algebra to solve for x. So we're going to subtract x from both sides, and we're going to add 3 to both sides. And we get x is equal to 6. So we want to make sure we move all of our x terms to one side of the equation and move all of our non-x terms to the other side of the equation. Okay, let's look at our second example. In this second example, we're going to need to use angle addition and angle bisector. Okay, we're going to use both of those definitions and postulates. So it says the measure of angle 2 is 6x plus 3. And it says the measure of angle ECD, which is this angle right here, ECD is 14x minus 6. Now the first thing that we know is we know that angle 2 is equal to angle 1. We know that angle 2, or angle 1 plus angle 2, is equal to angle ECD. Okay, those are the two things that we know. The first one, because it's an angle bisector, CP is an angle bisector, and the second one we know because of the angle addition postulate that we just covered. We don't know what angle 1 is, but we know it's the same as angle 2, and we know angle 2 is 6x plus 3. Therefore, angle 1 has to also be 6x plus 3. Okay, so for an equation, we could have 6x plus 3 plus 6x plus 3. Or we could say 2 times 6x plus 3. Is equal to angle ECD, which it tells us is 14x minus 6. Okay, our next step is to use the distributive property, which gives us 12x plus 6 is equal to 14x minus 6. And then we can subtract 12x from both sides. And we can also add 6 to both sides. So we're going to move our x's to the right side and our non-x's to the left side. Those two will cancel out, and these two will cancel out, so we get 12 is equal to 2x. We divide both sides by 2, we get x is equal to 6. Okay, and then our last section is constructing an angle bisector. So in this one, you're constructing, so you're only going to use your compass and a straight edge. So the first step here is to draw an angle, and it can be any size angle. Okay, so I'm going to draw that angle, and I'm going to label it A, the vertex A. The second step, it says to place a compass at point A and draw a large arc that intersects both sides of A. And we're going to label that arc where it intersects. We're going to label those points B and C. Okay, so here's my compass. I'm going to put the center at vertex A, and I'm going to draw my arc so the compass arc intersects with the sides. And I'm going to label those B and C. Now, with my compass at point B, so I'm going to put the tip of my compass, or the center of my compass, at point B. I'm going to draw an arc, and I'll change colors here. So I'm going to draw an arc from B, and then I'm going to do the same thing from C, okay, because every point on an angle bisector is equidistant from the sides of the angle. Okay, so I'm going to keep my compass setting exactly the same. And I'm going to label that point D. And then I'm going to draw a segment or a ray that comes from vertex A through D. And if I double check with my protractor to make sure that this is the angle bisector, I can measure those two angles. So here's my protractor. Okay, my angle is about 60 degrees. That's my larger angle. And then where my bisector is, it's about 30 degrees. Okay, so there's one of my angles. And here's my whole angle. Oh, that gave me the reflex of the angle. I want just the angle. which you can see here. I don't know why it keeps disappearing, but you can see that it is 61 degrees. Okay, so it's not perfect just because of a little bit of manual variance there, but it's about half of my angle. Should be, it's exactly half, just the way that you measure with manual tools like this. It sometimes gets a little bit off. Okay, so that is how you construct an angle bisector. So please jot down any notes or questions that you have, and we can address them next time I see you in class. Thank you.